Our last lesson in this chapter talks about graphing circles on a coordinate plane. And so there's an equation for a circle, just like y equals mx plus b is the equation for a line. Here we're going to talk about what equation makes a circle. So the first thing we want to think about is, what do all the points on a circle have in common? And, well, all the points are the same distance away from the center, right? This circle happens to have a radius of 3, so that radius of 3 would be the same radius no matter where we go around the circle. So then let's think about what the x, y coordinate tells us. So the x tells us how far we go to the right or to the left. Y is to the up or to the down. So do you see that little triangle that it makes? A little right triangle with an x and a y. But the hypotenuse is always 3. For every point on this circle, the hypotenuse is 3. And what is an equation that we use to relate the 3 sides of a right triangle? A squared plus b squared equals c squared. So this one's going to be x squared plus y squared equals 3 squared. And so instead of mx plus b or something, we are going to have an equation that looks like this. And normally we wouldn't even solve that for having a y equals. We would just leave it as x squared plus y squared equals 9. And it just comes from the Pythagorean theorem. All right, this is kind of the big equation of the day. The equation for a circle, as long as the center is at the origin at 0, 0, all you really have to know is the radius. And you can make an equation for your circle and it'll always be x squared plus y squared equals whatever that radius is squared. And so once you know the radius, you know the equation for the circle. It just gets a little more complicated if we move the center away from 0, 0. So this next box has our center at some point. We call it H and K. That's just a fancy way of saying an XY point that's at the center. And so the difference in the equation is that we still have an x squared plus y squared, because it's still a Pythagorean theorem field, and it's still equal to r squared, but we just have to adjust that x and that y value. So to adjust the x value, we actually subtract the center's x value. And for the y value, we subtract the center's y value. Does that remind you of a formula we learned earlier? The distance formula? Doesn't that sort of look distance formula-y? Because they're both based on the Pythagorean theorem. Let's just do a quick example of each. Here I've got a circle and it looks like its radius, well, it's starting at 0, 0 and its radius is 1, 2, 3, 4. So if the radius is 4 and the center is right at 0, 0, to write an equation for this circle, we just write x squared plus y squared equals 4 squared. And if you just want to skip right to the 16, that's fine. Beautiful. And this one's going to have us go backwards. So this time they're giving us the equation, and we have to try to figure out where the center and what the radius would be. Let's start with the center. We can tell that the center is not just at 0, 0 like the last one, because it has that funky stuff in here. So remember, x minus the x value of the center. So the x value of the center is 4. I know it says minus 4, but remember the minus is built into that formula. And so what is subtracted from y right here? That's y minus negative 2. So most people just look at that as we take the opposite of what's in the parentheses. X minus 4 gives us a 4. Y plus 2 gives us a negative 2. And then what about this guy right here? This is our radius squared. If the radius squared equals 6.25, how can we find the radius? By taking the square root of both sides. And the square root of 6.25 is 2.5. That tells me that my radius is 2.5. So to draw this, here's how we're going to do it. We're going to start at the center. We're going to go to 4, negative 2. And then from that center point, we're going to go 2.5 to the right. 2.5 to the up, 2.5 to the left, and 2.5 to the down. And then we're just going to sort of connect the dots. Do your best to make a pretty circle. And that's how we graph a circle from its equation. So I think this should be a pretty simple lesson as long as you just keep in mind these two formulas, whether the center is at 0, 0, or whether the center is somewhere else.